Welcome back for a series of lecture on digital image processing. Digital image processing, this lecture covers about spatial filtering. Spatial filtering and edge enhancement is a technique to enhance the characteristics of image, is a technique to improve the quality of discriminating the feature, is a basic techniques normally employed for various assessment for various studies. So this is very important area. The reason is you have data now. First we have initially registered the data. After registration, we wanted to start analyze the different objects, interpreting different objects by means of various small filters. This is very basics analysis of digital image processing, but more highly powerful. And this is normally being used in almost all studies, like image processing and its application studies. Let us discuss about the spatial filtering and edge enhancement today. So it is nothing but the filtering. You have already existing algorithm we are now going to apply, and you have 3 by 3 and 5 by 5, 7 by 7, 9 by 9. You have already existing algorithm, the numerical numbers which is kept and then move with the digital reflectance number. What will happen? You have set up digital number. In the digital number you have frequency, the amount of reflection is being recorded in the form of reflectance amount by means of pixel value or pixel element or pixel. So that's being represented, minimum value as 0, maximum value is 255. In between you have the histogram. What happens normally, you will not get the distribution uniformly from the lower signal to the higher signal. Now sometimes we are interested in lower signal, sometimes we are interested in higher signal. So sometimes that our interest will be a very less amount of reflection, so we need to highlight these differences. Spatial filtering plays a major role. You can take an image, you can divide the image into its spatial frequency and selectively altering certain spatial frequency to emphasize some features. This is how we normally do this. Know that there are 3 techniques. The technique to increase the analytical ability and to discriminate the detail. The 3 types of spatial features or filters are used used in remote sensing for data processing or image profile in a nearest neighborhood method and numerical. But this one normally we employ band ratioing and band ratioing. That this nearest neighborhood and image profile, it is generally to see the histogram and see the values of its distribution and all. But low pass filter and high pass filter is the normal use. Let us see the image filtering. Image filtering, what it does, image consists of low frequency and high frequency value. Filtering is done it on a single band, not with multiple band. Low frequency refers to less variability of DN value of the image. Example, there will not be much variations in DN values of deep water or in the dense forest. So not much variations you will find. That is you have to suppress the low frequency. High frequency refers to edges or the heterogeneity in image. Example, settlement area having roads, building, a park, a vacant land. So these are all the areas where we can use high frequency, high pass filtering and all. Low frequency refers to less variability in DN value, and high frequency refers to edges. High frequency refers to edges or the heterogeneity settlement. Image processing is a process involving to assess for the low pass and high pass filters on an image. Let us see one by one. This is how it moves. You have this is a box pixel of the area of my interest, and you have it is a pixel element, individual pixel, and whatever the reflectance which is coming here, it is being recorded as a number. And but what I am doing, I am going to enhance certain features what I am interested. So you can set your algorithm on your own, and then you prepare a 3 by 3 kernel. So this is 3 3 3 and a 3 by 3 kernel you take, and then you just move. What will happen? I am interested on the center, but I can also see the adjacent. This is 3 by 3 kernel. So your neighborhood neighborhood pixel value will be suppressed. Sometimes if you want, you can enhance also, or the center point also, which you can enhance, because I am interested. Once if you move, automatically the image will be smoothened and it will come as your expectation. This is the image profile. As I said, this is the first one, image profile. If you see it, it's blurred in nature, which you cannot be able to use. The way that this image blurred is there, you see, they have given with one horizontal profile, and this is the sample it's being taken, and this is the data value. You see, you could not be able to do, it's not looking feasible, and it's not, I'm not so comfortable on working with this type of images. So I must go with a either low pass filtering or the high pass filtering. The low pass filtering, what it happens here, it block the high spatial frequency detail. High pass filtering, it enhances the high pass. You see, it's very simple. Low pass filtering enhances low frequency value. High pass filtering enhances high frequency value. Understand like this, so it will be very easy for us to understand. This is the formula. In general, it is being used. So here, f of xy refers to pixel value at location xy, and the output for 3 by 3 mask is the average of the surrounding pixels. High pass filtering is one. This is the formula it is being used. And here you see, it's a formula. Now you have 3 by 3. Now you put 1 1 1 1, and you can move. Or if you want to put the high pass filter, like you put I am interested in the central pixel. I don't want to have. I want to suppress the adjacent area. You put -1, and then you move your cursor, and then this will multiply with the pixel value. Automatically it will suppress. Only the center point of the image will move, and then the edges will be suppressed. So what will happen? The high pass filtering will highlight the high frequency value. The low pass filter will enhance the low frequency value. You can also use mixture of representing high pass and low pass filter. This is the low pass. As I said, the low pass will take the informations of low frequency value and highlight. So this is the low frequency value details, and here it is being highlighted here. And you see, this is the pixel I am interested. I am going to use this kernel, so I am interested on only center point. If I can subtract, or I can multiply, or I can divide. If I subtract, what will happen to this? You see, the center point, it is being reduced, and the adjacent points are being suppressed. So this is the interest of the high pass filter and low pass filter. So this is average filtering, how it's being done, and the edges are enhanced. As I said, the edges, this is the edge. You can see even the next image, it shows that the edges of these images are wherever the road comes, railway, that's what high frequency value it is being exact. And this is how edge enhancement plays a major role. You can make use of this. You see, I am not interested. I am interested only this. This is the kernel. I am going to superpose this so that the center value will be highlighted. This is the end result of it. If you move your kernel like this, automatically edges of the features will enhance. You will get, you will be able to interpret either a lineament or a linear features, or a river, or a road, or everything. You can do it by using this one. So you can do it with only single band information. Either you take any of that images, and then you can apply edge detection. You see, the edges of the features are detected well, so that it is very easy to. And this is low pass filtering. You can see it's a blurred in color, and then high pass, there is a sharpen image, sharpening of all the objects is there, and this is the band it's being taken. This is the raw data. After you pass low pass, you see, again it's not good. You see what happens, low frequency values are highlighted better than this, but images are not looking so good. This is 3 by 3. This is the raw data, 3 by 3 kernel, 5 by 5 kernel of low pass, and the 7 by 7. But all this is, see, it depends upon where you can use this. Depends upon your experience working with this type of analysis in image processing will improve that, where you can put up your effort. So this is the high pass filter image. After high pass filter, you can use edge reduction. This is edge enhancement, and this is the image. You see that the edges of these images are enhanced. The corner roads and all the edges of these images are by applying this. The edge reduction by applying this. This is high pass filter. Only high frequency values will be increased. This is low pass filter. This is sharpening. This is edges. Only the edges highlighted. This is raw image, high pass center 9 by 9, high pass center 10 by 10 and 70. Sharpen image. And next come to band ratio. If you use single band, you will not get a very good result. Normally, if you go with the number of bands more, so you can enhance the details of spatial characteristics, and you can also suppress even the topographic characteristics. So illumination you can bring it very well by applying this. This is a single band data of TM1 band 1 blue radiations. It appears that that more brightness are there, even topography is suppressed. You see, once if you apply taking two bands like B4 band 4 by band 3, you see you have a lot of differences. Even this is one different types of rocks also being very easily interpreted, and topography suppressed, and then the difference of rock types is interpreted. This is shortwave infrared 1 divided by green. You see, you look up the table. This is infrared. You see that even the water bodies are highlighted here. And then now you apply and then see that how this is going to be. Color composite is combining several ratio image together. You will get a lot of ideas. And this is, you see, this is RGB image 4 by 3, 6 by 3, 7 by 5. And this is courtesy, it is given geology. You have many rock types, the same image you see. This is one rock type, second rock type, third rock type, fourth. You can describe more like this. So with this, the application of spatial filtering and edge enhancement comes to an end. From this, we can learn that a lot of application by using many small tools like high pass, low pass filtering, image profile, and you understand this and then do take a small image. Suppose if you are going to prepare geomorphology, or if you are going to prepare a lineament, maybe you apply some of for lineament assessment, edge enhancement will be more useful to wherever the edges are there, it will show. So you apply many of these technique and understand that how your remote sensing data can be very much useful for your own discipline. So with this, this lecture comes to an end. Thank you.